this is Yang Li, and he got his PhD from the Chinese Academy of Science in 2002. And he did his postdoc at Berkeley with James Landay, and now he's at the University of Washington. And he's going to talk a bit about some work he's done, most recently on something called the ActivityDesigner. And his area of interest have been in, say, rapid prototyping tools for ubiquitous computing applications. This talk is going to be external and go up on YouTube, so if you've got questions that are of a confidential nature, then we need to hold them to the end when the camera is no longer rolling. So without further ado. Okay.
Thanks, Rich. Let's just wait for the slides to show up. So, sorry for waiting. Okay, hopefully it's everything will be good. What's going on? Okay. Thanks, everyone. So I'm going to talk about my work on rapid prototyping tools for ubiquitous computing applications. First, I would like to give you a sense of what Ubicomp applications I focused on. So Ubicomp applications are those that can support our everyday activities in the physical world. One nice example here is Google Maps on iPhone. I think a lot of you know what it is. So the application can approximate the user's current location using widely accessible cell tower information. Based on the sensed location of the user, it can then provide useful services such as finding nearby businesses. Another example here is Intel's CareNet display. It gives caregivers a continuous awareness about the elder's everyday activities that are detected via RFID sensing technologies. So for example, when the elder forgets to take her medication, the icon on the display that depicts the medication status will turn red, so the caregiver knows what happened. So with advances in sensor technologies as well as computing infrastructures, there is a huge potential to build applications like these examples to simplify our lives and to achieve the vision of ubiquitous computing. So, however, it's very difficult to design Ubicomp applications. Compared to the well-defined desktop computing environments we are all familiar with, real-world environments are more complex, right? And our everyday activities in the physical world are more dynamic and less structured. Another problem here is Ubicomp often involves sophisticated technologies. So it requires higher levels of technical expertise to prototype and test the Ubicomp applications. So before I go on talking about how I am going to address these problems, let's first reflect on the success we have with desktop computing applications and the graphical user interfaces. So a common practice in user interface design is the iterative design that involves rapidly creating prototypes and testing prototypes with users to get feedback. So many tools have been developed for the process. One of the earliest successful examples is Apple's HyperCard. HyperCard allows people who don't have much technical background to easily create graphical user interfaces. Another example is Denim. So it's a tool for the early stage design of websites. I was heavily involved in the development of Denim. So it has been downloaded over 100,000 times since 2001. So it's really a popular tool for the early stage design of websites. So rapid prototyping tools like these examples have played an important role in the success of desktop computing and graphical user interfaces. So the purpose of these tools is not for creating full-fledged final applications, but rather they can lower the bar for interaction designers to create interactive prototypes and test these prototypes with end users to get feedback. So this turns out to be the key factor for producing useful and usable user interfaces. So to achieve similar success for ubiquitous computing, I would like to provide computational tool support for designers to easily design and test the Ubicomp applications. For the rest of my talk, first I'm going to briefly talk about my early work with Topiary for rapidly prototyping location-enhanced applications, a specific form of Ubicomp applications. And then I'm going to spend most time talking about my recent work on activity-based prototyping as well as its tool support, ActivityDesigner. So when I first started looking at the domain of Ubicomp design, it's such a broad space that it's difficult to be addressed by a single piece of work. So I focused on location-enhanced applications. These applications can provide useful services using the location of people, places, and things, right? So I already talked about what Google iPhone Map does at the beginning of the talk. Alcohol is another application. It keeps track of physical objects, patients, and doctors in a hospital building. So these applications are useful, but they are difficult to design and test. So location-enhanced applications often require a high level of technical expertise to design. For example, location and place sensor technologies are non-standard and complex. Although some toolkits are available for programmers, it often takes weeks or even months to build a location-enhanced application before it can be tested with end users to get any feedback. So it's too slow and expensive to iterate on designs, right? So for people who don't know how to program, such as interaction designers, there are no tools available at all. To address these problems, I created Topiary, a tool for non-technical designers to easily create and test location-enhanced applications. So there are two major research goals I intend to achieve with Topiary. So one is how we can allow designers to easily design location-based behaviors without programming, right? Another goal here is how can we allow a design to be tested with users in the field without having to deploy a location infrastructure. So location infrastructures are not always available, especially indoors, right? And there are also some complicated issues such as location to place inference. Okay. So here I would like to use a running example to talk about how Topiary addresses the design of location-enhanced applications. Let's assume we want to design a location-based tour guide. So these are the list of features we want to have. To design such an application, the first thing we want to do is to describe location contexts of interest, such as in or out of place, near or far from somewhere or somebody. So to allow designers to easily specify location context, I created a visual language in Topiary for this purpose. So you can first import a map image in the tool as background. Optionally, we can draw a road network on top of the map, right? So the road network will be used for constructing shortest paths at the runtime. Then we can add models of people, places, and things, right? So the map naturally represents the spatial relationship between these entities. For example, Bob is in the bookstore. In addition to presence context such as in or out, we can also specify proximity context such as near or far. For example, although Carol is outside of the parking lot, her proximity region intersects the boundary of the parking lot, which indicates Carol is near the parking lot while she is far from all other entities. So we can move people and things on the map to represent diverse spatial relationships. Then we can drop a recording window to capture location context of interest, right? So the recording window works like a screen capture tool. But instead of capturing pixels on the screen, Topiary captures spatial relationships of those entities that are included by the recording window. So in this case, we got Bob is in the bookstore, right? So then we can generalize a captured location scenario. For example, replacing the concrete place bookstore with any place. So of course, we can also capture richer location scenarios such as Carol meets Bob in the parking lot. It can be represented by multiple spatial relationships here. So the visual language here does not necessarily cover the entire space of location context, but it can cover a useful subset of location contexts, which are useful for rapid prototyping purpose. So then, actually, we can use the captured location context to specify location-based behaviors using a storyboard. So a page represents a screen of visual output, and the link represents a transition between pages. For example, when the user clicks on the Get Info button, the prototype will show the bookstore page when Bob is in the bookstore, and show the library page when Bob is in the library, right? And when Bob is in neither of these two places, the prototype shows a map. Another link here starts from the page itself. The transition can automatically take place as long as the associated scenario is true. In this case, when anyone moves near Bob, the prototype shows a table of friends. So that's how the behavior of the prototype depends on the location of the user, right? So once we have a prototype, we want to test the prototype with users. How can we do that? So traditionally, a prototype of a desktop application is tested with participants in a lab, right? But the targeted user scenario of location-enhanced applications are often in the field and when the user is mobile. And a prototype should behave based on the changing location of the user. So the controlled lab environment is no longer appropriate. As a result, Topiary uses a so-called Wizard of Oz approach to test a location prototype. So in such a test, a user walks in the field with a mobile device for running the prototype. Then the designer acts like a wizard, simulates the user's location on a separate device. Now I'm going to play a video clip to give you a sense how this works. So the designer can start a prototype on a mobile device, such as a PDA. Then the device can be handed to the end user. The designer can follow the user around in the field and then simulates the user's location on the map on a separate device. So the change of the user's location will trigger the application behavior. And a user can interact with the prototype on the mobile device. So Topiary has been downloaded over 1,000 times since 2004, and it's in use by researchers and university students. So I'm not going to talk about details here. I mean, if you're interested, we can talk afterwards. So here I would like to give you a summary about why we want to do iterative design with Topiary, right? So without Topiary, we can only explore. took us a few weeks to just explore a single design. And we had to program and deal with sensors. But with Topiary, we can explore multiple designs just in a few hours, right? And all the time during the design process, we only need to deal with a high-level abstractions, such as maps, storyboards, and wizard rods. Okay. So after I developed the Topiary, a natural start was how we can provide computational tool support for people to easily prototype and test a broader set of Ubicomp applications. To achieve that goal, there are two central research questions, right? So one is how we can go beyond location, right? So Topiary uses a map metaphor to represent the location context. So what would be an appropriate framework or structure to incorporate more diverse contextual information into the design? Another question here is how we can go beyond controlled environments for testing Ubicomp applications, right? For many Ubicomp applications, it's very important to test them in people's everyday lives. So Topiary's design can be tested in the field, but it's still a controlled environment, right? So the wizard has to follow the user around. So on one hand, we want these prototypes to be created at a low cost. On the other hand, we want them to be tested in people's everyday lives over an extended period of time, which inevitably require high degrees of realism and robustness. With these research questions in mind, I focused on a set of emerging Ubicomp applications. So these applications employ rich contextual information about people's everyday lives, and they show high value by supporting people's long-term activities, such as keeping fit and elder care. But again, these applications are very difficult to design test. It's more difficult to design test than location-based applications. So to understand why it's difficult to design and test these applications, here I would like to look into the design and development process of Ubifit, the application developed at Intel Research Seattle. Ubifit improves people's awareness about their physical activities by visualizing their workout status as flowers or butterfly. For example, the more exercises a user has done, the more flowers will be shown on the display, right? So first, Ubifit is addressing a very complex target domain. It supports keeping fit. Long-term activity could span years or even the lifetime of the user. Second, Ubifit requires high levels of technical expertise to prototype. It took a crew of technically skilled researchers 2 years to design, develop, and deploy Ubifit. And finally, because Ubifit is addressing a long-term activity, it has to be tested in people's everyday lives over an extended period of time so that the impact of the design can be observed, right? It would be impossible to observe the behavior change in a short period of time. So it turned out these difficulties are not just with the particular project of Ubifit. My colleagues and I conducted the interviews with 11 professional interaction designers, and we found many designers encountered similar challenges. And we found that field research is very important for Ubicomp design. And it's important to bring field findings into a design process as a context for design. And currently, there's no tool support for that. And because the high-level technical barriers exist for experimenting with new ideas, it's very difficult and expensive to push an earlier idea to functional prototype and to the real-world experiment. So these are the problems I intended to address. So my research goal at the high level is to provide computational tool support to allow non-technical people to easily prototype and deploy what used to take a team of researchers weeks or months to do so. To achieve that goal, I created ActivityDesigner, a rapid low-threshold prototyping tool for Ubicomp applications. So here I would like to use a real example to talk about why ActivityDesigner is useful in design Ubicomp applications. Ubigreen is a project conducted by researchers at the University of Washington, Carnegie Mellon University, and Intel Research Seattle. So Ubigreen addresses environmental protection by encouraging people to do transportation activities that have less impact on the environment. Right? So the designer started the design by describing what are possible transportation activities, right? So the information can come from field research or solely based on the knowledge of the designer. Then the designer created a prototype called the Ubigreen phone application using graphical storyboarding and prototyping by demonstration. As we can see here, the designer used a lot of examples to describe how the leaves of the tree should change based on the number of green activities a user has done. Okay. So then the designer deployed the prototype to multiple participants. And it only took a few button clicks and copy paste to deploy such a prototype. So it's really a lot easier for deployment. The prototype was tested with multiple participants over 2 weeks. And participants' transportation activities were detected in a combined way. Some basic transportation activities, such as running or biking, are detected by mobile sensing platforms, which are developed at Intel Research Seattle and UW. Some transportation activities which are difficult to be detected, such as driving and taking bus, these activities are reported by users themselves. So during the testing process, the designer was able to monitor multiple tests at the same time on a remote computer. So as we can see here, the designer had 2 kinds of designs, and each of them was tested with 6 participants. So it's like a between subject study. So the designer intended to find out which design is better. And the designer can revise the design and redeploy the design anytime remotely. So the designer didn't have to collect all the mobile devices back in order to deploy a new design. He could just do it remotely. Okay, so hopefully at this point you got a rough idea about what the ActivityDesigner does. So now I would like to flesh out more details about the tool and the theory behind the tool. So the process I intended to support with ActivityDesigner is a so-called activity-based prototyping. So the process starts with field research, then it goes through the loop of activity analysis and modeling, interaction prototyping, and in situ testing. At first glance, the process seems like a simple extension of the iterative design process. But what's special here is the important role human activities are playing. So human activities are used as first-class objects in the entire design process. Activities are transformed from field observations to activity models to computational constructs. So back to the question, how can we incorporate diverse contextual information into a design, right? So how can we incorporate context-rich human activities into the design process? To answer that question, I looked into activity theory. Now I'm going to talk a little bit about theory before we get to the technical details. So activity theory offers a consistent view about the context, and it also gives activity hierarchy. The hierarchy includes activities, actions, and operations. For example, for the long-term activity, keeping fit, it can be carried out as a set of actions, such as lifting weights and running a treadmill. An action can in turn be decomposed as a sequence of operations, such as pushing the quick button to start and running. So the hierarchy captures the essence of a long-term activity, but it's inadequate to capture the situational factors that might be associated with activity, such as location information. We cannot fit the location information into the hierarchy. So for Ubicomp design, I introduced a few new concepts to the hierarchy. For example, for the running action, it can happen in multiple situations, right? Running with friends at the gym or running alone at the park. So I call the combination of an action and a situation a scene. So a scene is a direct observation about people's everyday lives. And then the same action can serve for multiple purposes, serve for multiple themes. That's a high-level activity structures. For example, running for keeping fit and running for fun. So a theme is an equivalent concept of activities in activity theory. So the hierarchy actually, the framework here underlies the entire activity designer system, as I'm going to show in the next few slides. So now I'm going to talk about the key features of activity designer in supporting each of these steps. So field data may come in as a free text, images, video clips, or metadata such as structured questionnaires. So this field data can be imported in the tool as a collection of scenes or observations. So you don't have to do a field research to use the tool. You can just add these observations based on your own knowledge, right? Then based on these individual observations, then we can create high-level activity structures, themes. A theme is an aspect about people's everyday lives. For example, eating healthy and having fun are two aspects for staying healthy, right? So each theme is associated with a subset of scenes or observations. Clicking on a theme will make Activity Designer only to show a subset of observations. So on these activity models, observations and themes are maintained visible throughout a design process. That's how they can form a context for design. So designers can picture target activities in their mind. As I'm going to show in the next few slides, these activity models are also an important resource for creating functional prototypes, and they are also a basis for generating computational constructs for running these prototypes at runtime. Okay, so then the next step is to create functional prototypes. In Activity Designer, we can create multiple prototypes at the same time. So we can think globally in terms of how each of these prototypes should behave to provide coordinated support for target activities. The storyboard here shows the design of the health monitor application. So I'm going to use this design to talk about the key features of Activity Designer. Okay, let's do something concrete here. The first feature we want to prototype here is turn the purple fish to a goldfish when the user has achieved her weekly exercise goal, which is running in the gym 4 times a week. So the key part to prototype this feature is to specify the condition, right? When the user has run in the gym 4 times this week. To design such a feature, the designer can drag the running workout action to the link to create a condition. A default query is constructed. Then the designer can interactively customize the query into a target form, such as specifying time periods, confidence value, activities of interest. Yep. So the activity query language allows designers to easily specify activity queries over noisy event streams. So we can specify activity occurrences of interest using a list of filters. The specification here represents all the running workouts of the user or her friend in the gym or park. We can also use a theme to represent a class of actions or situational factors. The second specification here represents all the actions of the user for having fun. So in addition to graphical storyboarding for prototyping, we can also demonstrate how the interface output should change based on the user's activities. For example, based on the 3 examples at the bottom of the screen, the system can learn the mapping between the numerical value of the nutrition status and the visual output. So the dial will rotate at the runtime based on the nutrition status. For those advanced designers or users, they can also script rich behaviors. So I'm not going to talk about this in detail here. So then we can test a design anytime with simulated activity data, right? So in the activity designer, we can also debug the design, like we can interact with the prototype like an end user can. So we can test multiple prototypes at the same time. Okay, then we can test these prototypes with the real users on the target devices. So ActivityDesigner provides 2 options for running a prototype. A prototype can directly run on the ActivityDesigner virtual machine if the target device is a high-end device, such as a tablet PC. For the low-end devices, such as a mobile phone, the virtual machine will not be able to run. So in that case, a prototype can be automatically converted to a web application. It's actually based on Google Web Toolkit, so it's really cool. So at the runtime, users' activities can be detected via real sensors or reported by users themselves. I mentioned this earlier. So all these components are communicating with each other through Activity Server, a key component in the ActivityDesigner runtime architecture. So the architecture allows a new component to be easily plugged in. For example, if we have a new sensing technology, we can plug it in, and it will work. So these are interfaces for reporting activities and these computing constructs such as sensor wrappers or database structures. They are all automatically generated based on activity models we created at the very beginning of the design. So it really makes the deployment a lot easier. So the designer doesn't have to care about all these technical details. And we can analyze the design easily in Activity Designer. We can load in a session and replay the activity logs with the prototype. We can also use the same query language to generate a graph. For example, like what's shown here. So we can do some simple statistical analysis in Activity Designer. We can also export the data, the queried data, so we can do some more analysis in other statistical tools. Okay, so next I'm going to talk about how I evaluated the Activity Designer. So first I conducted a lab study with 10 participants. The participants were asked to design the key features of 3 applications. Here I would like to briefly talk about what I found from the study. So participants were able to finish most of these tasks, and we got positive feedback. In particular, although none of my participants had a background in activity theory, they were able to easily understand the concepts and the representation of activity framework. Excuse me. So the study also revealed the need to have a more expressive way to specify queries. That's why that was the motivation for me to enter the query language in the current version of Activity Designer. So then I conducted a lab study to evaluate the query language in particular. 6 participants were asked to specify queries in response to 15 questions in natural English. For example, for the question, has the user been in the classroom or theater for 5 minutes? The participants was required to specify the query in the dialog box like this. So participants were able to finish most of the tasks without help. And in particular, for those participants who had experience in SQL and Ubicomp development, they commented the query language is much easier than SQL, and it's still expressive enough to specify a range of queries. Activity Designer has also been used by other researchers in their design projects, such as for the domain of environmental protection and social awareness. So I talked about Ubiquitous earlier. So from these studies, I found the framework as well as the tool support, the Activity Designer system were effective for designers to describe and prototype Ubicomp applications that could address large-scale activities. I found that designers were able to create and deploy prototypes in situ in just a few hours rather than a few months. And there have been some positive results in terms of how Activity Designer allows people to create new applications. So I have released Activity Designer as open source. So please download the tool and give it a try. So in conclusion, my research in this area contributed to rapid prototyping tools, Topiary for prototyping location-enhanced applications, and Activity Designer for design Ubicomp applications for in-situ testing. In addition to software artifacts, my work also contributed an activity-based prototyping process. In particular, the activity framework provides a new way for describing and structuring contextual information. So looking forward, I would like to continue working on new technologies that allow people to effectively leverage the rapidly growing computing power and the information resources. So if we look at the trajectory of interaction design, from desktop to ubiquitous computing, we always trying to incorporate more information into the design process, right? So Activity Designer provides a platform for activity-based design. So I hope to work to explore more tool support for design Ubicomp systems that could address large-scale activities. I also intend to empower end users to be able to easily create personal gadgets. So these Google gadgets are actually created with ActivityDesigner. So they are fully interactive, and they can behave based on users' activities, such as transportation activities and daily exercises, right? So based on my experience with the ActivityDesigner, I hope to develop a higher level to, or more specialized to, for end users to be able to easily create Google gadgets, right? So we have millions of gadgets easily created. And yeah, so I was supposed to give you a live demo, but my computer crashed. So I mean, I can do it later. So another direction I intend to work on is the data-driven design and development of interactive systems. So as user activities are getting more and more complex, it's very important for us to analyze the massive data we collect and to identify users' needs and to optimize interaction behaviors. These systems are the projects I have been working on in parallel. So Activity Prism is a tool for analyzing people's behavior, activity patterns. It provides multiple ways for people to look into activity data. And the CARS is a system for automatically extracting interaction logic from testing sequences. So it can actually extract a storyboard from sequential data. Finally, I would like to work on activity-based context-aware computing. In particular, I would like to study the issue of how to organize computing and information resources based on users' activity. The benefit here is then we can provide users with information and computing resources that are relevant to their current activity. So I think these nice Google products, such as iGoogle and Google Mobile and Google Desktop, they provide a great platform for me to explore this research agenda. So another research area I have worked on.
Go back, what were the tabs? So it's one, planning, vacation. So are these tabs based on activity? Is that the idea?
So actually, that's a good question. So I think so. iGoogle can already do something. So we can already do some activity-based stuff with iGoogle. So it's like each tab actually. I studied iGoogle. So each tab here is like job search, family visit, and planning vacation. So like each tab is already like a container of activity, right? So we can add some relevant gadgets to that tab. So yeah, so iGoogle already has the nice feature of this. So I think it's really a nice platform to work on. Another area I have intensively worked on is pen-based user interfaces. So I have worked on problems such as gesture recognition, ink parsing, and pen-based mode switching. So that's one example, interactive motion. At this point, I would like to thank my advisor, James Landy, as well as my collaborators on this work. Thanks very much, and I can take questions. Happy.
So as you move, you have the example of designing for designers and designing for end users, and you have that example of deploying this, the gadgets to the end users. What do you have to do to make that transition from one group of people, designers, to end users? Is there a big difference, or like designers smarter?
So the assumption is that designers have designers have more expertise, right? So so for end users, we certainly need to provide higher level support for them, right? So I think for so my work has been focused on tool support for designers. So with these tools, we can know the domain better. So as we know the domain better, we can provide better tool support for end users. So I'm not sure I answered the question. Or
Yeah, so it's like the first set of tools for designers is more open-ended and general, and then
exactly,
the tools
right.
evolve.
Exactly. So tools for designers. So tools for end users. Normally, the environment should be there should be more stuff has been instrumented, right? So we can only support end users to customize interaction behaviors in a smaller range, right? For designers, it's like everything is from scratch. So it's like white paper. Then I draw my design. So these tools allow designers to explore a larger space. So I think that's one of the differences between tools for designers and tools for end users.
You mentioned the Wizard of Oz model for taking the application out into the field and observing the users. On the phone or the device or whatever it is that you're looking at the experience, is there logging going on or somehow
Yes.
to capture the screen so you can see what the user is doing?
Exactly. So, all right, let me. It's kind of slow, but I can answer the question at the same time. So, right. Oh, jeez. So, we can actually record and replay a test, right? So when we replay the test, and we can observe how much time a user spend on each screen, and we can even the tool can also show the trail the user has walked, and we can also analyze the storyboard transition, and so it's the entire test is recorded, and we can replay the test. Yeah. Any other questions? Yeah.
So in the beginning of the presentation, you mentioned that when you are designing for Ubicomp, you usually need to design very sophisticated systems. I'm just curious, whether it's the sophisticated systems or whether it's more about repurposing the existing systems to work in a new context. I mean, a simple example is many times when we talk about super high-end technologies very high density, say, storage devices, stuff like that. So 8 gig capacity in a very small flash drive versus even a 32 MB outdated flash drive might serve the purposes in the new context. So I'm just trying to figure out whether it's more about making use of the existing systems in a new context versus trying to develop super hi-fi systems from scratch. And what's your perspective on this? I'm just curious about
So for this, I think your question is whether we want to design entire new system from scratch, or we want to enhance existing systems.
Yeah, essentially, what I'm trying to understand is when you're trying to design for ubiquitous computing, should you directly go for developing highly complex systems from scratch versus trying to analyze, okay, what are the needs that I am trying to serve first, and then seeing are there enough existing technologies which can somehow support, because different technologies have different curves in terms of how much sophistication they need.
Right.
So
that's a good question. So I think as a first step, you always want to understand the existing technologies and existing activities, right? So then you identify what are the breakdowns in the existing activities with existing technologies, right? So once we understand that, then the next thing is we want to come up with some new designs to address those problems. So with these tools, you can create the mockups for the new systems you are thinking about. Then you test the new designs with users to get feedback. Then the next step is how can we realize the new design idea in the actual settings, right? It could be just a simple extension of the existing systems, or it could require us to redesign and rebuild the whole thing. So these tools, they provide a way for people to figure that out, right?
Yeah, I mean, that's actually one of the reasons why I liked it so much, because if you look at it from the point of view of, say, databases, it's not a very complicated database per se. It's a pretty primitive. I don't want to say that but it's relatively primitive in terms of the core database functionalities. But the way you have repurposed it in the context of the problem that we are trying to solve, I think that's really brilliant.
Right.
And
so thanks for your comments first. I think the good thing here is the key thing here is we want to develop tools that really serve for the purpose, right? Even the tool is fantastic for one purpose. It's not necessarily the right thing for another purpose, right? So it has to be appropriate for the goal you want to achieve. Yeah.
There's one last thing. Have you actually thought about sort of scalability of these tools in terms of, say, initially if I develop a gadget, especially the iGoogle gadget when you mentioned, it's like iGoogle gadget has the capacity to be deployed over, maybe a couple of million people can use it if you have enough adoption. So have you thought about how this sort of rapid prototyping tool can scale? And in a way it goes back to the point which you were making earlier.
Yeah, that's definitely a good question. So I think one issue these tools suffer is definitely scalability, right? So the main purpose of these tools is to create a mock-up, right? To figure out design space, to understand what you want to design with. For the iGoogle thing, that's something so basically, in terms of scalability, ActivityDesigner is much better than Topiary, and you can really create a lot of realistic stuff with ActivityDesigner. But for that future work, I proposed tools for end users to create Google gadgets. That part I intended to create some new tool support, right? Even higher level tool support for end users to easily create the final stuff. That's something final. It's not just a mock-up. So, yeah.
Scales as well as gadgets.
Yeah, exactly.
Which is,
That's brilliant.
Okay. Thanks.
Well, I guess that's it. Thank you very much.
Thanks.
And,
Thanks very much.
we have lunch right away.